Hello everyone, how are you going? This is Miss Sue again, and this is actually the second part of our video of naming ionic compounds. So my previous video is actually naming simple ionic compounds. So if you have jumped straight into this video, I would advise you to watch the other one first, because this is a more of like an extension. It's naming polyatomic ionic compounds. So the previous one will provide you with more basic knowledge. Yep. So let's get started. So previously we learned about a periodic table and how we could actually look at the columns of the periodic table to sort of figure out the charges, whether it's positive or negative, how many electrons should be given out or received for this ionic compound to be formed. Yeah. So in this lesson, we are actually doing sort of like rewriting involving polyatomic ions. So what are polyatomic ions? They are actually ions with two or more atoms. It could be from the same element or different elements. Yep. In our homework, it's an exhaustive list that is provided. I have actually shortened it to use it for the purpose of this tutorial here. So we have carbonate. So a carbonate has a CO3. So that means that it actually consists of one carbon and three oxygen ions. Yeah. The two negative on top is actually, it actually means that it has a -2 charge. Yeah. So this means that a carbonate actually has 30 protons but 32 electrons. And because it has 2 electrons more than its proton number, therefore it has a -2 charge. And it's really hard to calculate the charges for polyatomic ions. So that's why we have to use the list provided. So sometimes once you keep doing it, you will sort of like memorize the charges. So what we're using today is hydroxide, nitrate, and sulfate. So let's keep going. We are actually learning previously how to write the formula given the name of an ionic compound. So in this case, it's magnesium nitrate. And previously we have learned that magnesium, or anything that's written first, is actually a metal element, and the one that's written next, it could be non-metallic. Yeah. So in this case, magnesium is actually on the second column over here. So it has a +2 charge. Yep. A nitrate is actually a polyatomic ion, and therefore we have to use the list provided. Yep. So we know that nitrate has a -1 charge. Yep. So magnesium has two positive charges. So what does that mean? That means that magnesium will need to give out 2 electrons. Yeah. So for nitrate, nitrate has a -1 charge. That means that nitrate can only receive 1 electron. So what's going to happen here? Yeah, magnesium is giving out 2, but one nitrate can only receive 1. So yes, you are correct. We will need 2 nitrates, if that makes sense. Yep. So we need 2 nitrates, but 1 magnesium. Yep. So therefore, we need 1 magnesium ion and 2 nitrate ions. And therefore, we can actually rewrite the formula as below here. So yes, we used the shortcut previously and it was really useful. So let's do it again. So magnesium has a +2 here. So the 2 goes down to where the nitrate is. And nitrate has a -1. So the 1 goes down to where the magnesium is. But we do not write 1 because it's like we don't write it. It's like a common sort of notation that we don't write it. So how does this symbol happen? That means that we need 1 magnesium. The bracket over here means that nitrate is actually written as NO3, and that's why it's the nitrate in the bracket. Yep. The 2 here means that we need 2. Yep, nitrates. Yep. And as we can see, the charges are all gone after we write the formula. We can't write the charges in the formula. So it is all gone. So this is how we write the formula for magnesium nitrate. Yeah, let's do another practice. So oops, I forgot. So this is the periodic table, and as promised, we need to cover for transition metals. So transition metals are metals that's written with the Roman numeral behind them. So for example, iron 2, bracket 2, it means that it has a positive 2 charge. And yes, iron 3 will have a positive 3 charge. Lead 2 will have a positive 2 charge. Lead 4 will have a positive 4 charge. So this is the additional thing that we have to know to keep going. Yeah. So, okay, let's practice this. If you are confident and you can do it already, feel free to pause this video and try it on your own. Yep, or else let's just keep going. Yep. So if we look at iron 3, we know that yes, iron is a transition metal. We do not need to refer to the periodic table to know that it has a positive 3 charge. Yep. And sulfate, okay, we have to look at this list and know that, okay, in this case, sulfate has a negative 2 charge. Yep. So how is this going to work? So iron has a positive 3 charge, so it needs to give out 3 electrons. Okay. So sulfate said, no, I can only receive 2 electrons. So how is this going to match? Yep. So we need to be thinking about the lowest common multiple. So the lowest common multiple for 3 and 2 is actually 6. Yeah, so it means that iron needs to give out 6 electrons. So we need to have 2 iron ions to give out 6 electrons, and we need 3 sulfate ions to receive the 6 electrons, if you know what I mean. So because of this, we are actually using the number here. So for the formula. So the number for the sulfate, the negative 2 charge for the sulfate, the 2 goes into the iron over here, and the 3 from the iron goes into where the sulfur is, if that makes sense. So iron is written as Fe, and because we need 2 iron ions, we write 2 at the bottom. Yep, and sulfate is SO4. So whatever that's in the bracket, it's the polyatomic ion. So that's sulfate, and we need 3 of that. So it's written that way. So now we know that iron sulfate can be written as Fe2SO4 bracket 3. Yep. So let's do another practice. Yep. So aluminium carbonate equals what? So what's the formula for aluminium carbonate? I have prepared the periodic table and the list of polyatomic ions. Feel free to pause now if you want to do it on your own. Yep. Or else let's just keep going. Yep. So if we look at aluminium over here, we know that aluminium belongs to the column with the +3, and that means that aluminium actually has a 3 plus, a 3 positive charge. Yeah. So if we look at carbonate, yeah, carbonate, as discussed before, has a 2 negative charge. So we need 2 aluminium ions and 3 carbonate ions. Yep, if that makes sense. Yep. So or else the shortcut is we just write the numbers across. Yep. And Al stands for aluminium and CO3 stands for carbonate. Yep. And remember not to write the charges, the positive and negative charges in. Yep. So yeah, this is our lesson for naming polyatomic ionic compounds here. So please do your homework, stay safe, and I'll see you at school soon. See you then. Bye.